Hi there, welcome to this new tutorial in which we're going to be doing something more interesting with the geometry. In this case, we're going to load the geometry, a very complicated geometry from STL files to model this aneurysm. So this is a vein in the body, and an aneurysm is like a bubble that sort of like appears unexpectedly, and it's a bad sign. Like, you shouldn't have these on your veins, like an aneurysm, right? Because they can exploit. Anyway, so we're going to be modeling the flow of blood in the aneurysm and the pressure. It's a computational fluid dynamics problem, right? CFD. But the interesting part is also that we're going to be using AWS to run the simulation. I do have a notebook here that I'm going to share with you, where you can see how to run this simulation, load the STL files, all of that. How to do that here on Google Colab. The issue, however, is that if you do it on Google Colab, it's going to break because depending on whether you're using the free version or not. At least I'm using the free version, and with the T4 GPU, it will break after like 1 or 2 hours, I think. So that's a problem, because on AWS, running this on a V100 EC2 instance, EC2 P3 instance, which is a V100 GPU, on AWS it took like 48 hours, which was like approximately $150 per hour. No, sorry, sorry, for the 48 hours, right? Which was like $3 per hour, which was the expected cost. Yeah. But maybe that part is not that important. The point is that it takes a long time, right, to run this simulation. So be prepared for that. At any rate, I'll show you how to set it up if you're interested. Alright, so let's see. I already described the problem. You can read more about it in the documentation. We're going to focus on just setting it up on AWS. Okay. So let's do that. Right. So we go to AWS. Need to open an account, of course. We go to EC2. Here in our instances dashboard, let's see here, like instances. We go to launch instance, right? And here in the marketplace we type NVIDIA. We wait for a moment, or click enter. Yeah, you click enter, wait for a moment to see the AWS marketplace Amazon machine instances. Okay, so now we select the NVIDIA GPU-Optimized Amazon machine instance, the first one that appears, which should be like $3 per hour. That was indeed the expected cost for me. Like, I made the calculation and it does cost that. So subscribe now. Okay. Yeah. Perfect. So we're going to do P3.2 it's large. If you do this for the first time, I think you're going to get like this kind of error. You have requested more virtual CPU's capacity than your current virtual CPU limit of 0 allows for the instance bucket. So you need to go to this link that I put here for you. So yeah. So here you do EC2 instances and region. I think I'm doing Oregon, US West Oregon. And so all P instances, yeah, that's fine, all P instances. Request 8, that's what you need for the V100 GPU. If you wanted to use the A100, I think you would need like 96 virtual CPUs, right? The issue is that if you request that many, which I tried, they are going to tell you that you need to talk with their sales team to get that approval. So I haven't done that. But 8 is very easy. So you type 8 here, and then you're like, I want to do research on AI and ML and run my simulations faster, whatever. That should be good enough, okay? In my case, I already did it, so it's fine. So I just need to select the P3 large instance with 8 virtual CPUs. That should be fine. Create a new key pair. KP tutorial, right? KP tutorial, create pair. Then that's going to download automatically the .pem file. Allow everything for sure if you want. And that should be it. Let's launch the instance, okay? By the way, we're going to be connecting via SSH from VS Code, so I'll teach you how to do that as well. Yeah. Okay, so you click here, like successfully launched the instance. So you click there, and it's going to send you here. Oh, click here again. So you click then on connect, and now you have the instructions to connect to the EC2 instance, right? Via the SSH client, which is what we're going to do. So here we have like the commands we need. Yeah, so let's go to VS Code here. Let's open the terminal in VS Code. Okay. I need to see the two downloads, by the way. Yeah, go to downloads. Yeah, so we're going to do this chmod thing on our, we run this command on our key pair, right? And then we need to connect to our instance with this other command here, right? One thing to know though is that you need an extension, right? So go to extensions, type SSH. I'm using this one, remote SSH by Microsoft. I recommend you uninstall it and install it again because I have a big headache. I had installed this a time ago, if that's your case, and it was not connecting. I was reloading, I had to reload a lot the window. It was crazy, and the issue got solved finally when I uninstall the thing and just install it again. Okay, so maybe you need to do that as well. Make sure to have a fresh install of that thing. So once you install it, you can do on a Mac Command-Shift-P to open here the commands here on Visual Studio Code. Then you type SSH. By the way, I learned to do this from a very cool YouTube video. I'm going to be adding this on right now on the video on YouTube to give credit to that person. But anyway, so you type SSH and you click here, add new SSH host. Okay, so now you need to copy and paste this command here, but there's a catch. So remember that our .pem file is on downloads, on the downloads folder. So here, where we in this terminal where we are in the downloads folder, we're going to copy this path, users, my name, right here, and we add the slash. So make sure you get this path correctly. Don't forget to add the slash here after downloads. Okay. Another thing to note is that even though here they suggest you connect with the root user, the NVIDIA Optimized Amazon machine instance, or virtual machine instance, complains, like it asks you to use Ubuntu for whatever reason. So please use Ubuntu if you're following this tutorial to the letter, okay? So we use Ubuntu as the user, and then we click enter, and we click enter again, which should be the first option, whatever, right? Okay, host added, and then we click connect. If everything went well, we're going to see here this question. We click yeah, sure, enter, continue, the first option. And let's see, it says that it's open in the remote. I think you can open the terminal here as well. You probably should open the terminal to see what's happening. I don't know, this happens a lot, it's annoying. Just hit retry. Just hit retry. Don't lose hope. Yeah, as you can see, it's kind of installing drivers. I believe you just have to wait. It might complain again, and you just hit retry, or here reload. Reload the window. I'm just going to hit retry a few times, because I believe the thing is that you have to wait for these drivers to be installed by the NVIDIA thing on the virtual machine, on the EC2. So we just wait for a little bit. We keep trying. Again, you may want to try to reload the thing. I feel like if you reload, yeah, same thing. I'm convinced you just need to wait for the drivers to be installed. It takes a little while. I think reloading does help. Activating extensions, let's see. Yeah, I think it's just a matter of waiting. Yeah. Finally, when it finally works, you're going to be here, and you're going to see Ubuntu, and yeah, this is where you need to be. By the way, please don't forget to click here and open the folder to connect to the remote. You do want to do that, then here click OK, so that you can see the file system. Yeah, there's the offers. So here you're going to be able to see the file system, which is going to be useful when we want to take out the outputs of the simulation, of course. Okay. Right. So we open the terminal, and now we can start doing the sample. Right. We need to install NVIDIA Modulus actually, but here I have a few commands for you. Yeah. So you need sudo apt get install NVIDIA Docker to like the NVIDIA Docker toolkit. Oh, not here. This is the ground VS Code window. I think I can probably close this, or oh no, I don't really care. Let's leave it there. But this is where you need to be. So okay, sudo apt get install NVIDIA Docker toolkit. Here you just click enter. Okay, we have that. Now sudo docker pull this. The one I'm going to be using is the 24.07. That one is the latest. I don't have the link to that here, but I'll be adding it in the description. There's like a link where you can check like the latest Docker image of NVIDIA Modulus. I think it's build.nvidia.com or similar, I think. But anyway, like you go to, or it's MVC or something like that. Yeah, so you find the latest version of the NVIDIA Docker tag, and you put it here. Okay, sudo docker pull. We pull it, And this one also takes like a couple minutes. Yeah, so we're going to wait for this, and I'll be back in a moment. Hi, so this is done. It took like quite a few minutes. Sometimes it's faster, I don't know. I still don't know why sometimes it takes longer. So we downloaded the new image for the NVIDIA Modulus, right? The Docker image for NVIDIA Modulus. We have it here, now we should run it, right? That's like the next step. And we have the command here. I don't know why it's... there should be a sudo there, right? Okay. So, so sudo... Yeah. Not here, but here. Okay? And don't remember to do 24.07 here. There's a problem. I have it here. Yeah, this is a common issue. Yeah. So error response from daemon unknown runtime specified NVIDIA. So it's sudo. Yeah, you need to restart the thing. So sudo system daemon reload and sudo system whatever restart docker. Okay. Now we run the command and it should work. Yeah. Okay, there you go. So now we successfully installed NVIDIA Modulus and we're running the Docker container. We have the ID here, our workspace on the Docker container. Okay, now let's run that sample. Now for running that sample, we're going to need a few things. Yeah. I'm going to move this command here for you. You're going to have access to this notebook. So for the Aneurysm example, you need to have git LFS. So we do that here. Install git LFS, large files for GitHub. And as I said, in the Aneurysm example, if you go to the repo of Modulus Sim, as I mentioned, for the validator, you need like certain additional files, right, from NGC. So, let's see, and we want to download that stuff in the right place. So this is Modulus Sim examples aneurysm.py. So here, let's see, we're here, right? Oh, we need to clone the NVIDIA Sim repository. Oh my god. I don't want to confuse you guys. Yeah, of course. Let's see where I have that link. Yeah, so you go to getting started pretty much. Yeah. Let's we need to clone first the NVIDIA Modulus repository, right? Before we even run the sample, right? So here in getting started, here are a few of the commands we have used. We want to make sure we clone not the Modulus repo, but the NVIDIA Modulus Sim, right? Modulus Sim repo, okay? So this one. Okay, so we clone the NVIDIA Modulus Sim repository. Now we have it here. So cd Modulus Sim. What do we have here? The examples, okay. cd examples. What do we have here? A lot of examples. cd Aneurysm. What do we have here? The Aneurysm example. The STL files are here, but for the OpenFOAM validator, we need these additional files. So if we go to this link, which is this one, we're going to see here this zip file with additional files. So we copy the wget command, which you have here anyways, and wget, okay. So we get the zip file. It's a little bit of a large zip file. 665 megabytes. Yeah, 665 megabytes. So we copy this. Little zip file. Okay, great. Now that we copy the zip file, we have it here. We unzip the thing. Unzip examples sim.zip. Yep. And we're only interested in, let's see, I think I have another command here. Yeah. So let's wait for that. We're only interested in the Aneurysm OpenFOAM folder, right? Because if you go to the code here, it's going to look for .openFOAM, an OpenFOAM folder with data, right? With this data. So we only want that folder with that CSV file. So here we're going to copy that. Yeah, from examples sim, examples Aneurysm OpenFOAM, because that's the path. Yeah, so here we have like examples sim, right? If you go into examples sim and ls, you're going to see there's more stuff, like essentially the path that I just showed you. So go back, right? You need to be here on Aneurysm, right? Go back. Make sure that if you type ls, this is what you see, right? Okay. If you are sure that you're here on Aneurysm, on that directory, then you copy the OpenFOAM folder in this location, and because it's a folder, you need to add -r recursively because you want to copy the stuff that is inside the folder, right? So now we have it here, OpenFOAM folder with the file we need for sure. So we can remove the examples sim.zip. We can also remove, as you can see, it's now gone. So we can also remove the example sim because it has more stuff than we need and it's very large in terms of file sizes. Okay, so, but because it's a folder, it's going to complain, right? So you need to add -recursive to remove everything that is inside. So now we have only the folder we want. Okay, perfect. Now that we have that, we can run the example by doing python aneurysm.py, but before you do that, there's an issue you need to watch out. You need to reduce the batch size, otherwise you're going to get an error. Let me see if I also have the link for that error here. Yeah, I have the link for this error here, because I want to show you this. Yeah, so could out of memory error. Like if you don't reduce the batch size is here, like on the configuration file. The batch size for some parameters here. So if you don't reduce the batch size, it's going to give you an error of could out of memory. It happened to me after like a few hours of random simulation, which is painful, very painful. And so you have a few options. supposedly it's better if you do the A100, but that one is expensive and it's very hard to get approved by AWS to use that one. It has a lot of virtual CPUs, so we're using the V100, and the only way I got it running on the V100 is by reducing the batch size by half. So let's reduce the batch size. Okay, and for that I gave you a few commands here to use Vim, in case you're unfamiliar with Vim. Okay, like you need this batch size on the config file. Okay, so Vim and paths to our script. Okay, so here are the commands anyway. Okay, so Vim, it should be config /config, what's the path again? Config.yaml. Oh, it's config.yaml. Okay, so we go here to the batch size line, and I think the command is, I'm not an expert on Vim, press I to enter insert mode. Okay, so in this case this one would be 550. This one would be 325. This one would be 2600, and this one would be 3000. I arbitrarily tried to reduce it by half. You may want to try other values, but it's painful when you run this for hours and then it stops, right? So reducing it by half seemed like a good idea, and it worked. So 155, right? Okay, so now we click escape to exit insert mode, and to save the file it's this command, semicolon WQ, and then press enter. Okay, WQ, enter. Okay, perfect. We reduced the batch size. Now finally we can run that sample. So we do python aneurysm.py. Excited about this. Okay. See. There you go. So it's going to take 48 hours for you. Obviously I already did it once, so I'm not going to run it again. My recommendation is that, funnily enough, I already recorded the second part of the video, but in that part of the video I terminated the instance. I think it's better if you stop it. Do not necessarily terminate the instance. And the reason is that I believe that some files may get corrupted, so be careful about that. So you may want to make sure that if that happens to you, you can access the files again and download them from the EC2, because some files are so large that they may get corrupted. I think the checkpoints file may have had problems for me. Fortunately, that file wasn't key for the post-processing, but I think that one got corrupted. So anyway, that's going to happen later in the second part of the video. I also think that if you open a second terminal, you may be able to access the files as you go along. So maybe you can try it in 12 hours and see if that's good enough for you, because I think it may be, For example, it took me 48 hours to reach iteration 1.5 million. which is actually just the cutoff, you know, like the match steps. That's all it was, to be honest. So it took me like 48 hours to get there, but I think it just feels like the training loss is fine, like around here. So that's interesting, you know, when you're running such a large simulation, you may be able to just like keep it running here and just access the files from here. I have commands here that I'll share with you to copy stuff in the container, out of the container, right? The second part of the video I'm going to teach you how to do that. But yeah, you can, I feel like, do it as you go along, and I think it should be fine. You may want to check how the replication looks like, the visualization looks like, right? So yeah, let's get ready for the second part of the video. I'm glad we made it to this point. Yeah, thank you. Hi, so the simulation finished, and it took a much longer time than I was expecting on this GPU V100, NVIDIA V100. So I started running the simulation on Friday afternoon or evening, and it finished on Sunday afternoon or evening, kind of like around those times. Yeah, so pretty much, I think a little more than 2 days, like more than 48 hours. So that's a long time, and it turned out to be a little expensive for me. So I really need to shut this down soon. I think it costs, well, I was hoping around $3 per hour, but I guess we have to do some math there to see the real price after all. I think it may be close to the real price, isn't it? Like, I mean, like, let's make it efficient very, very quickly. Python 3, yeah, so around, no, it's 48 hours. Yeah, so it's around $3 per hour. Yeah, I think so. I think it's very close to the expected price. So it took like 48 hours anyway. So the next step is to take the output files out of our virtual machine instance. So let's do that. The way we do that is by taking them out of the Docker container, right? First of all, we need to paste this stuff out of the Docker container. Copy and paste, right? So the way we do that is like sudo docker cp. Wait. Let's copy the current directory we're at. Like we're here, right? And we can see the output files are here. Okay, so we do sudo docker copy, and then we take the ID of the container, which is this one that you see here. This is the ID. We paste it here, and then semicolon, and then the path, which should be workspace aneurysm, right? Output. We only care about the output files, of course. Outputs apparently is in plural, so it's outputs, and then we space, right? We do a space here, and then that should be obviously yeah, the path on the VM. So the path on the VM, let's just do outputs, I guess. Why not? Let's try it out. I think that should work. So we don't need oh, hey, that's interesting. Yeah, I think this command we have to actually copy and paste it somewhere else. Like, let's step out of Python there. Like, you just open like another terminal, I guess, right? I'm just doing this as an example. Obviously, this one is fine, but let's delete this one. Yeah, so we do it on the actual VM. This is how we do it. Yeah, now we copy it to outputs and we can see I was hoping we could see it there. There you go. I realized something right now. Yeah, so what you need to do to see the files here is to paste sudo docker cp and the path in the container, but also home ubuntu /outputs. See? Again, so here we are in the container. We see the container ID and now we can see the outputs folder and it shows up here beautifully. This is just awesome, to be honest. Amazing. Exactly what we wanted, right? And again, this is the command sudo docker copy path in the container and then directory in the virtual machine instance EC2. For some reason, if we don't add home ubuntu, it just goes we don't know where. you need to add home ubuntu in order to see the file showing up here in the file explorer. Obviously, this is the remote file explorer in our Ubuntu virtual machine on AWS EC2. So now that we have it here, we can download it. We click. You cannot just move it to your file explorer. You need to download it. In this case, it's going to show up on my downloads folder. So that's just great. Yes, I was saying here I have the outputs file on my downloads. Now I have here the output files, the constraints, stuff. Well, this is the one that matters, the weights, the monitors, and the validators. Yeah, so that's it. Yeah, did I already show you the price? Yep, here it was a little expensive, so I'll be shutting this down. Remember to do that. Let's go to EC2 Instances. This one, instance state, and terminate instance. Okay. Yeah, so this was this is actually the first video I'm recording. What you're going to be watching is actually what I'm going to be recording myself next in real life. In real life, I'm going to show you next. Well, I'm going to record next how to set the simulation up. Obviously, I don't want to run it twice. So the first part that I'm recording is actually the results, which is today, which for me is the Sunday evening of August 4th. I finished this weekend the simulation, running the simulation. So that's what I'm showing you right now, how to take the output files, and I'm shutting down my instance. Then I'm going to record just how to actually set up the simulation, but I'm not going to run it twice because obviously it's a significant amount of time, slightly more than 48 hours, and a significant amount of money, like obviously $150. That's more expensive than I wish it to be. So perhaps in the future we're going to be studying ways to run this faster and hopefully also cheaper, in a cheaper manner. It's really important apparently to figure out how to optimize the running times, because otherwise you can run into large bills. But in this channel we're going to help you to avoid that as much as possible. So yeah, that's where we're at. Thank you. Hi, so welcome to the final part of the tutorial. We are going to be dealing with the post-processing of the output files very quickly. I have here in the notebook the scripts that I used to first of all, let's see, loading the model weights, right? Well, first of all, you instantiate the architecture, then you load the model weights, and then we need to have the geometry files. That's going to be useful. We plot the results. I have scripts here to normalize the geometry, which is based on the script of the sample, aneurysm.py. So yeah, and we replicate this figure, which is a very good replication of the figure over here, right? And I have here a few tips for debugging. At the beginning, I had a hard time replicating it. It turns out that I was doing something wrong. So it's important that you make sure that you are doing plotting the right thing. Normalization was important. That was one of the issues. And making sure that you have to make sure that it's not a visualization problem. So it's maybe useful to have a table here for debugging. In my case, it was a visualization problem and not a model problem, and so I only realized that by debugging a little bit. Lastly, we try to visualize the velocity magnitude with this script. I couldn't really get a sense of how they came up with this visualization in particular. The angle we have here is more like, if we go to ParaView, let's see, yeah, in ParaView, if you visualize the files, I think this is sort of like the angle we have, like, because we're going deep into the Z axis, right? Z axis. So yeah, this is kind of like the angle, like, right? Which is kind of like the shape we may have here, right? Where it's like the velocity magnitude is like close to 0 here, right? But it's more intense here, right? As you can see here. Now, this is not the velocity magnitude on ParaView. This is more like the component W of the velocity, but obviously it correlates with the velocity magnitude. Right, on ParaView you only have the one component, W, but here it's like, it takes into account like the 3 components to get the magnitude, right? So yeah, basically that's the script. I'm not going to go over the code like super with a lot of detail. I'm just going to run the cells and explain a little bit. So first of all, we load the NVIDIA Modulus library. We install that stuff. We can use the CPU runtime, that's fine. We're only doing inference, we're not doing training right now, so that should be fine. Well, while this gets installed, I'm going to add the files I need, which as far as I'm concerned right now, it's only this one, the flow network weights, right? So that's what we're doing. Okay, so we installed the NVIDIA Modulus library. We reset the runtime, and so I just started like clicking here on the configuration, like we run the cells, like we need the configuration file here. This is how we write the config.yaml here, right? We instantiate the configuration object here, then we instantiate architecture. This is how we do it. We follow the sample, 3 inputs, 4 outputs. Finally, the important part is loading the model weights, which I just uploaded here. So this is how we upload the model weights. It's important you use this line if you're using the CPU runtime, which is good enough for now. We get the STL geometry files from GitHub, and yeah, let's see. We put them here in our directory, so we're going to copy them. Like this. Yeah, so now we have them here, the STL files. We plot the results. I have figured we only need this geometry file to get the visualization, so that's good enough. There are a few scripts here to normalize the inputs and yeah, make sense of the geometry. And then lastly, we visualize the pressure with some sort of a scatter plot in 3D. Okay. What's taking a while is actually doing the inference of the model. That's the line that, you know, like takes a little while, like this one, right? And everything else is fast enough. Okay, so now we have it here as an image. Yeah. So congratulations, we successfully replicated the pressure visualization. As I said, you may want to learn how to create a table out of the model parameters and outputs, and then plot that, because then you can be sure that the issue is either with your model or the visualization if you have an issue. In my case, I spent like a few hours trying to make sense of a visualization. It was not looking like it was supposed to look, and then I realized, oh, it's not the model, like it's actually the visualization, and I only realized that until I actually debugged stuff like bit by bit. So anyway, so for the cross section, I came with a similar script. You know, that is like a little brute force. You know, when you're doing the visualizations yourself with your own code, you have to be creative. You can ask ChatGPT for ideas about visualizing this stuff. It's super useful, but in the end, the best I could get was, I'll show you, this approach to visualizing the cross-section. I think here what they do is some sort of like 3D stuff that allows them to see the depth. If you have ideas about how to replicate this, please share perhaps a link in the comments. I would love to see like a script to replicate this visualization exactly for the velocity magnitude. Perhaps you can share a GitHub gist with an idea about how to replicate this stuff. That would be super valuable. But well, this is the approach I used. Like I have like additional points that I add to see the interior here, like to sort of like sample the interior and see the magnitude of the pressure there, of the velocity there. That's the approach I used. Yeah. And there you go. We have visualized our model, the outputs of our model, right? So ParaView, also this one with these streamlines, I'll be having to do perhaps like to record. I will need to record a crash course on ParaView so that we become experts on ParaView as well. Because right now, what I'll show you is how to make sense of the VTP files. Like this is part of the output of the simulation, the VTP files. You upload them here, and then you click here, for example, like interior here. Like you can click here on this, right? And then here you have properties, display, geometry. On display you can go here, and on coloring you can choose like the pressure, for example. And if you choose the pressure, then we have a very similar visualization to what we have here, right? Right, this is the visualization, which is just like the one we have here for the pressure. On ParaView, this is how you sort of like visualize it, right? And again, you have all the other variables here, right? The magnitude of velocity and stuff like that. Yeah, but the streamlines, I guess that will have to be part of another tutorial in which we go deep into ParaView to perhaps replicate something like this, the velocity magnitude. If someone also can share a few tips about how to get these streamlines on ParaView, that would be greatly appreciated too. Yeah. So lastly, I want to show you how to make sense of the TensorFlow data. So for that, we're going to upload another file. Well, in fact, let's first create a directory here. We'll need that, my TensorBoard data. So here, we're going to upload the events, like here, like events.out TensorFlow events, this file. We upload it here. We make sure that it's inside a folder. It needs to be like on a folder, because here we're going to load TensorBoard and we're going to specify the directory where the TensorBoard file or data is, right? I'm doing now this on Opera because this TensorBoard on Google Colab doesn't show up on Safari. I don't know why. So we're doing it here. I don't know about Chrome, but you may need to try like a different browser other than Safari, because TensorBoard on Google Colab doesn't show up well on Safari. Okay, so this is how you load the TensorFlow events, and you can see the time series, and there are like the monitors and the training and the validator cards here. Like, so for the monitor, let's see the training stuff, right? So this visualization here, train loss aggregated, this one should correspond to this stuff, like the training loss and the iterations, right? As we can see, we reached the max iterations like in 48 hours, which was like 1.5 million, which is just like the configuration, the original configuration. An example, like its max steps is 1.5 million. And indeed, that's where it stopped. But I would say that arguably we reached the minimum loss much sooner than the max step. That we don't need to wait for the max step, I think, but whatever. That's where it stopped, because that was in the configuration. In the future, I will make another tutorial for the transfer learning, which promises that if you already did it once, then you can change the geometry perhaps, or a few parameters, and you can have new iterations of the simulation or new runs of the simulation much faster, right? Finish them much sooner. But this is where you see that kind of data anyway. Yeah, the learning rate, the loss of the specific constraints, the partial differential constraints here. And what else? The validators. Let's see. We have here validators that we added. Yep. So that's part of the post-processing that we have here. I'm going to be sharing these notebooks with you so that you can have them as a reference. Please let me know if you have any questions. Please let me know if you have any ideas about future tutorials. I've talked to some of you who have connected with me over LinkedIn, so please do that. I'm going to share here a link to my profile. Please feel free to connect over LinkedIn. Send me your problems. I can help you with code for free because I want to learn what you're doing. All I want to ask back is like ideas. Like, if you tell me what you would like to see here on the channel, People have told me transfer learning is one of the things they want to see here on the channel. I'll be covering it, right? So yeah, let me know your thoughts, and I'm excited about exploring new technologies and methodologies in scientific computing with you. Thank you.